Hello friends, very good morning to you all, and myself Dr. M.A. Channaya, former principal at Dr. Shivkumar Mahaswamy College of Engineering, Bangalore. Friends, in today's session, we are going to learn about the design procedure followed to design a V-belt drive. As the name indicates, this V-belt drive will have two pulleys, grooved pulleys, and they are called as the sheaves. One is the driver pulley, the other one is the driven pulley, and they will have a center distance of C. I have represented the diameter of the smaller sheave as D and that of the larger one as capital D. Friends, the V belt is also called as VV belt, will have a trapezoidal cross section as shown with a width W at the top, thickness T, and this taper will be at an angle of 40 degrees. Friends, when I say design a V belt, it means we have to design all the parameters or the elements connected with that. So basically we have got three elements, namely the driver pulley, the driven pulley, the V belt, and we have to find out for the power to be transmitted what should be the diameter of the larger pulley, the smaller pulley, what should be the cross section, and how many belts or how many strands are required to transmit the given power. So friends, here in the design of this V belt drive, which is also called as VV belt drive, I am going to take up a simple example wherein both the speeds of the driver and driven pulley are given and also given what is the power to be transmitted. So let me say you have this data, power N to be transmitted is say some 8 kilowatts, and the diameter of the smaller pulley is say equal to 80 mm or you can say 100 millimeter. And speed of the smaller one, that I call it as N1, that is the driver pulley, we can have it as 1200 rpm, and that of the larger pulley N2 equal to say 250 or 300, you can say 250 or 400 to be specific, say 400 millimeter. So this is the data given, friends. With this data, I should be able to find out how many number of belts required. So friends, when I say design of a belt drive, basically you will have to find out how many belts are required to transmit the given power, what should be the cross section of the belt, what should be the diameters of the driver and driven pulley. Friends, now I am going to follow two simple steps to design this V belt drive completely. In step number one, I am going to determine, we are going to determine the size of belt, which is also called as cross section of belt. So friends, in the first step, let us see how to find out the size of the belt. Say friends, here we have a term called D, or you can say the size of the belt depends on the equivalent pitch diameter given by DE is equal to DP into E of B. So this is given in the machine design data handbook of all these chapters. So DE is equivalent pitch dia, DP is the diameter of the smaller pulley or the smaller sheave, and I will write down here DE is equivalent to equivalent pitch dia, which depends on DP and FP, where this DP is D1 or D, that is the diameter of small pulley or small sheave. A grooved pulley is called a sheave. So, this is given to be equal to 100 mm in the data. And friends, this FB is called small diameter factor. Small diameter factor. Friends, this small diameter factor depends on the transmission ratio. So, we will find out what is the transmission ratio. Friends, you know very well, to find out the transmission ratio in any of these drives, you have to have two different speeds or two different diameters or two number of teeth on the driver and driven pulleys, whatever it may be. So, here we know the speed of the larger one, speed of the smaller one. So, transmission ratio, I will say TR, transmission ratio is equal to N1 by N2, because the small sheave rotates at a higher speed. So, this is equal to 1200 divided by 400, and this works out to 3. Friends, for this transmission ratio 3, if you refer to the machine design data handbook, there is a table which will give you what should be the value of this FB. So, if you refer to this table, let us say referring to table in MDDH, in machine design data handbook, okay, for corresponding to transmission ratio TR is equal to 3, you will have, we get FB is equal to 1.14. So, this value is given in the data handbook. It all depends on the transmission ratio. So, generally it is greater than 1. Friends, we know this FB, so we will be able to find out what is DE. DE is equal to DP into FB. So, DP is D, small d, multiplied by FB is 1.14, and that is 100 multiplied by 1.14. Say you are getting 114 millimeter, it is a dimension. So, friends, we have got the equivalent pitch diameter. So, once you know this equivalent pitch diameter, friends, there is a table in the machine design data handbook which will give you the equation for the power transmitted. So, we have a table in the data handbook. You will have the different cross sections, say cross section of belt, and then you have got this DE value. So, cross sections are represented by A, B, C, D and E. There are 5 different cross sections that are generally used, and they have given you the value of this. Say maybe this is 110, this is 114, 150 and so on. So, here A is one cross section, B cross section, C, D, 5 different cross sections are there. And friends, depending on the value of DE you obtain, so you are going to select a cross section of the belt. For example, if you have got this DE equal to 114, you are going to select B cross section. If you are getting more than 114, you should select C section. Friend, so in this problem, according to the value of DE, we are going to select B cross section. So, the cross section selected based on this is B section, and this will have a width at the top equal to B or W is equal to 14 mm, and this will be 7 mm. It will have a width is equal to 14 and the thickness is equal to 7 mm. This is what the cross section, and this angle will be, as I told you before, it is 40 degrees. So, this is how we select or arrive at this. And friends, you can also see in the same tabular column I wrote, they will also give you what is the power that can be transmitted by each such belt B. So, for every section they have given you what is the power transmitted. So, for example, for B section or C whatever it may be, depending on the section, they will have a expression by name N star, that is the power transmitted by each belt. So, this will run in terms of the velocity, and also I write down here this equation will be in terms of dE and velocity. So, we know the diameter and speed, we can find out the velocity, and then the value of dE we have found out based on the diameter of this smaller sheave. So, this N star stands for the power transmitted by each B section belt. So, this is how you are going to get. So, this you will have to calculate. Once you know the value of D and the value of velocity, you can find out this N star. Friends, in the first step you are able to find out what is the value or the cross section of the belt required, and in the second step, step number 2, which is little lengthy, we are going to find out the number of V belts required. Each belt is called a strand. So, they will also say how many number of strands. Each belt is called a strand. So, we have to find out how many belts are required to transmit this power of 8 kilowatts. Friends, again in the machine design data handbook, there is an expression, say number of V belts required is given by I, which is equal to N times FA divided by N star FC into FD. In simple terms, friend, number of V belts will be, in simple terms, the total power to be transmitted, that is N. It is 8 kilowatts in this case, divided by N star, power transmitted by each of the belt we have selected. And these are the different parameters which specify the length of the belt, the angle of contact, etc. Now friends, let us see how to find out this. Here friends, this N for B section is available, and say we are going to get some power here. This is N is the power to be transmitted, power to be transmitted by the drive, that is equal to 8 kilowatts. And here this term N star is the power transmitted by each belt, of B section, of B cross section. I told you this can be obtained if you know the velocity and the equivalent pitch dia. So, we know this value, we know this as 8 kilowatts, this also we have calculated. So, friends, once you are able to find out N star for the belt selected, we know this already. So, if we divide one by the other, approximately you get number of V belts required. But in design, we are going to take all other parameters which connect the severity of service, the length of belt, the angle of contact, etc. So, friends, here let me tell you what these terms FA, FC and FD stand for. I will say here A to find FA, This FA is called correction factor for industrial service. So friends, as the name indicates, this factor depends on the severity of usage, the point of application where it is used, and for how many hours it is used, etc. So if in the data it is not mentioned, so you can always take as the medium duty with 10 to 16 hours per day service. So you can obtain a value. So this works out to FA is equal to 1.2. That is available again in the machine design data handbook. There is a separate table which to give the value of this FA. Friends, sometimes they will say this is used in a crusher, and in that case you will take heavy duty, and this will be more than 10 to 16 hours. This factor may be 1.4 and so on. So this is the value of FA. Whenever the severity of service or the usage is not specified in the problem, you can take it as 1.2. Friends, let's go to FC. What is FC? This FC is called the correction factor. This is correction factor for length of belt, for belt length. So as the name itself indicates, this value FC also again obtained from the table MDDH. It depends on the length of belt. And friends, we have two sheaves or two grooved pulleys having diameter D and D, and center distance you have taken it as C, and so with this data we should be able to find out the length of belt. L means the length of belt, which is equal to 2C plus pi by 2 D plus D plus D minus D whole square by 4C. So this is the equation again available in the machine design data handbook. You need not bother about this. Friends, so what are the terms that are involved in this equation to obtain length of belt? One is C, the center distance. Again I would like to tell you the center distance of these pulleys or distance between the centers of pulleys may be given or not given. Say if it is given, use that value given in the data. If not given, how to find out? Friends, remember, whenever C is not given, so you have to find out two values of the C. One is the maximum value, the minimum value, and adopt an average value. Friends, here if the C is not given, in the handbook it says the maximum center distance, maximum C or C maximum is equal to 2 times D plus D. The D is small d is the smaller diameter, larger D is the diameter of the driven pulley. We know both, so we can find out this. It is also given in this question as 2 times maximum D, and this minimum D is 100 have given. The transmission ratio we have got 3 into 100, this will be 300. That is to say 400 into 800 millimeter in this example I have taken. Then again you have got C minimum. C minimum it says is 0.55 D plus D plus T. The T is nothing but the thickness of the trapezoidal cross section. So we know this value, we know D, we know small d, thickness you have taken as 7 mm for B section, And friends, you can also get what is the value of C minimum. So, all these calculations you will have to carry out whenever the center distance between the pulleys is not specified. So, once you have maximum center distance, minimum center distance, you can adopt an average value of these two center distances, and you can say C is equal to half of C max plus C minimum. So, you know C max, you know C minimum, you take half of the sum, you will get the value of C. Friend, D is the diameter of the larger pulley. We know this is 300, 400, this is 100, 3 times, that is 300 mm. Small d is 100 mm. The value of C is given, or you can calculate using this formula. So, you will get the length of belt. Friends, once you have the length of belt calculated, then there is again a table in the data handbook, table in machine design data handbook, which will give you depending on the length of belt. So, I will say here depending on the length, and you have got different cross section like A, B, C, D, etc. A, B, C, D, E, a different cross section. What are the length you have got? Suppose say 2345, you will get what should be the nominal inside length of belt. This table will give you nominal inside length of belt. So, friends, so corresponding to every length you have the value of this nominal inside length. Say for example, here we are using B section. So, you should see what is the value under this B. If you are using D section in some other problem, you should see what should be the value of this. So, once you have the length of belt L, you can find out the nominal inside length of the belt. And once you have this value, the same table will give you what should be the value of this FC. So, FC is obtained based on the nominal inside length of belt, comma, the cross section of belt. So, once you know these two, you can find out FC. Say in this problem, you are getting FC is equal to 0.99. It's only an assumption I am making. You get a value around this. So, we know N star, NA, FC, and finally you will have to find out FD. Third part, to find FD. So, friends, this FD is the correction factor. FD is the correction factor for the angle of contact or for the arc of contact or angle of contact on small pulley. That is again obtained from machine design data handbook. Friends, here he said it depends on the angle of contact on the small pulley. Friends, generally for all these V-belt drives, we are using an open belt drive in which both the driver and the driven rotate in the same direction. Here, friends, the value of FD depends on the angle of contact. So, for the given drive, you will have to find out what is the angle of contact. Say this is theta s, and in the machine design data handbook, they have given a simple table in which you have just two columns, and it says in the first column what is theta s. Theta s means the angle of contact on the smaller pulley. smaller sheave, and then the value of FD. So, if you are able to find out the theta s for the given drive, then you should be able to find out what is FD. Friends, here let us see what theta s is. Theta s, you know very well, in an open belt drive, the angle of contact on the smaller pulley is lesser than 180 and is given by the formula theta s is pi minus 2 sin inverse d minus d by 2c. So, this is again available in the machine design data handbook. So, you need not have to remember this. So, theta s is the angle of contact on the smaller pulley, and this pi represents 180 degrees. So, this is 180 minus 2 times sin inverse of d minus a. D is 300, the other one is 100, and this is 2 times center distance, 2 times c, what are the value, the average value, c average we have calculated, we can take. So, friends, say you are getting some 162 degrees. So, once you have this theta s calculated, you come to this table, see where the theta, suppose theta is 162 degrees, and you can just see under this what is the value of this FD. So, friends, we are able to calculate all these factors, namely FA, FC, FD, and the power transmitted by each belt. So, after calculating all this, we are left with the substitution of these values in the equation for the number of belts. So, friends, now if I take up that I, the number of belts I is equal to n times FA divided by n star FC FD. Friends, n is the total power to be transmitted, that is given as 8 kilowatts, FA 1.2, n star power transmitted by each belt we have selected, say some 2 you are getting for the V cross section, then multiplied by FC is 0.99, suppose say this is 1.1. So, all these values are simply assumed. Only when you refer to the data handbook correspond to the exact value, you will know what exact value of FA, FC and FD are. So, friends, here you can say 2 4s are, so it is approximate some number of belts, say you are getting 4.7 belts. Friends, you cannot have fraction belt, so we will have to say adopt I number of belts is equal to 5. If it is 4.8, 5, 3.9 is 4. That way you will be able to get the number of V belts required. So, friends, this particular chapter is also a very important chapter in machine design too, and this has got only 2 steps. If you have thorough practice, I am very sure you will be able to score full mark in this chapter. Friends, I hope you are all happy with the presentation I have made on this chapter, design of V belt or VV belt. And if you like this channel, please like it, subscribe and share the information with all your friends, and have a wonderful day. This is Dr. M. H. Channaya signing off.